The first two operations you could be asked to do while simplifying a radical expression would be addition and subtraction. They follow the same steps in that you really need to focus on simplifying the radical completely, which we've talked about already. If the terms have the same number on the inside of the radical, then you simply just add or subtract them. If they don't have the same number inside the radical, then there's nothing else you can do. So let's look at these two examples and practice simplifying our radicals and then adding and subtracting. So for our first example, as we rewrite it, let's just simplify the square root of 45, but let's just write out our basics here. So the two square roots we're adding, and we have two square roots that we're subtracting. Now the square root of 45 is going to be 9 times 5 when the 9 is the biggest square number. Square root of 180, that's the square root of 36 times 5, where 36 is the biggest square root number that goes into that. 32, a little more basic, that's 16 times 2. And 98 is going to be 49 times 2. So as we have each of these all simplified just as far as factoring is concerned, now we write them out as their separate square roots. Square root of 9 times square root of 5 plus the square root of 36 times the square root of 5. That's for the one with addition. And for the one with subtraction, square root of 16 times the square root of 2 minus the square root of 49 times the square root of 2. And so you can see for both of these, we're just trying to reduce each of these radicals completely by breaking down each of them into their factors with the greatest square number, or what other method you choose. For the one on the left, that brings us to 3 times the square root of 5 plus 6 square root of 5. And for the one on the right, that brings us to 4 square root of 2 minus 7 square root of 2. And now we're at this point where you can take a look and see if they have the same number inside the radical, which both of these examples do. So we have 3 plus the square root of 5 plus 6 square root of 5. You treat this just like you were combining like terms, and so if we have 3 of something plus 6 of something, that is a total of 9 of something, or 9 square root of 5 for your final answer. In the other example, if you have 4 of something and 7 of something and you're subtracting them, and they both have the square root of 2 inside, then you would just subtract them like you would subtract anything else. And if you have 4 minus 7, that would be a negative 3. Sometimes students get a little concerned about the fact that you have to subtract and get a negative, but think of it like terms. It makes it a little more simple for you to end up with that correct answer of a negative 3 square roots of 2. Now, one thing not mentioned was this scenario where there's nothing left for you to do. So let's take a look at this example, and again, we're going to start by reducing each radical completely, which means that we're going to write out the square root that we're adding. And so the square root of 192 is going to be factored so that you have 64 times 3. 64 is the greatest square number that goes into that. 50 is a little more straightforward. It's 25 times 2. And as you set this up, you can say, okay, that's 64, square root of 64 times the square root of 3, plus then the square root of 25 times the square root of 2. And you simplify one step further, and you end up with 8 square root of 3 plus 5 square root of 2. Well, and now as we take a look, we see that, well, there's not the same number on the inside of each of these radicals, so they're not like terms. You can't add them together, so that means that this is actually your final answer, and there's nothing left for you to do. The other operation you'll have to do is multiply your different radicals. So here we have a multiplication sign inside here. We have these multiples out front of our radicals just to make sure we can actually know what parts we're multiplying. Here these steps are slightly different, but they does start with reducing each radical completely. Then you're going to multiply the values on the outside. That'd be the 4 and the 2 of the radical with each other, and multiply the values on the inside. Now this is after we've completely simplified, and then you want to verify the radical is in fact simplified completely, and we'll look at an example of that a little bit later. So let's start by reducing each of these. So as we start out, you have the 4, and then the square root of 32 times 2 times the square root of 12. And then if you factor each of those, 16 times 2, 16 is the biggest square for 32. 4 is the biggest square number that factors out of 12. And then we can separate that out from our products. 4 times the square root of 16 times the square root of 2 times this 2 that was there originally. And then you have the square root of 4 and then the square root of 3. So as you simplify each of these, you have to be sure you notice that it is multiplication for all of them. So this is 4 times 4 now. Square root of 2 stays as a radical, times 2 from the original 2 as a multiple that was there, and then times another 2 from the square root of 4, and finish with the square root of 3. And here's where we multiply all the values on the outside. So as you take a look, then that would be your 4 times 2 times 2, which is a 64. And then you multiply the values on the inside, so 2 times 3 is equal to 6. And then that would be your final answer, because as you verify, the very last step here is that no, there is no other square number that goes into 6, so 64 square root of 6 would be your simplified version of this multiplication problem. And that would be method 1, where you just simply simplify each radical individually first and then multiply. So let's take a look at method 2. Method 2 is very similar, but all you notice is that your steps are switched for step 1 and step 2. So the first thing we're going to do is the multiplication of the 3 and the 5. So let's start this example, which is different from a previous one. We start with the 3 times the 5, because we're multiplying the values on the outside, which would be 15. And then you have to multiply 27 times 8, and you get 216. So you are going to get larger numbers underneath this radical. So as you go through your simplifying process, you have to think about the biggest square number that goes into 216, which would be 36. 36 times 6 is 216, and that leads us into our simplification. So you have the square root of 36 times the square root of 6 for the inside part. So this 15 stays out front. Square root of 36 is just 6, and you're multiplying there. And then you are multiplying by the square root of 6. And 15 times 6 is equal to 90. And that would be your final answer. Because as we verify here, you see that, well, 6 can't be simplified any further either. So this is your completely simplified version of the radical. So this is the second method, where you multiply the insides first. And what that does is that gives you a slightly larger number with your radical, but there's less factoring for you to have to do as a kind of a trade-off in that larger value that you have inside here. So let's take a look at the comparison between the two methods. So here we're going to do the same problem, but we're going to use different methods to do it so you can compare and contrast, and that might help you choose the way that you do it. So I'm going to go through the examples very quickly just so you can see the process. So in method 1, you start by simplifying each of your radicals. So that'd be 3 times the square root of 4 and square root of 3 for factoring out the 12. To factor out the 24, you get a 4 and 6. So that would be square root of 4 times the square root of 6. Now we just do the square root of each of those parts we're able to. So 3 times 2 times the square root of 3 times 2 times the square root of 6 from above. And then we finish by multiplying the stuff on the outside. 3 times 2 times 2 is 12. And you have the square root of 18. But as we take a look, this 18 can be simplified further because 18 can factor into a 9 times 2. And so then what you have is 12 times the square root of 9, square root of 2. Square root of 9 is 3, of course, and then times the square root of 2. So your final answer is going to be 36 times the square root of 2. And you can see that that step there at the very end, you have to be careful for to verify. Whereas in method 2, you instead multiply the insides first to create just one radical. So 3 times the square root of 288. It's a larger number, so you figure out what the biggest square that goes into that, and that happens to be 144 times the square root of 2. So now you have 3, and then the square root of 144 is 12 times the square root of 2. And as you multiply those numbers out front, that's 36 square root of 2 as your final answer there. And so you can see in method 2, there's less steps in your process, but you do end up with a larger number underneath that radical. Whereas in method 1, there are definitely more steps, and you have to double check to make sure that that 18 is in fact your final answer. So you might have to do some more factoring in order to come down to your completely simplified method. It doesn't matter what method you choose. You choose whichever one makes more sense to you. Some students prefer the factoring because they're pretty good at factoring all those parts and don't like those larger numbers. Some students want to do less steps and take a little bit more time to think about that square number that goes into 288. So that is your choice that you have to make. Just make sure that you understand that there are